So 1s2, 2s2, and 2p.
3.
It's not that hard, is it? Not yet. No, it's not.
Did you just say not yet? Here it goes.
All right. Really, it is. None of it should be that hard. It just takes practice. Okay. I bet you can do oxygen. All right. Do oxygen. Do oxygen. Tori. Tori. Do oxygen, please. No, we're not going to do that. Hey, we got some work to do, okay? Party's too hard on the weekend, you know, you got to stay awake. Are you really? I've been sick all weekend myself. You didn't get back to water without you? All right, let's do oxygen. Stay focused. Oxygen. Less chit chat, more focus. Hmm? Yeah, you can go on, go with her knee on if you want to. She's on fire.
So is it not going to be another sub-level until we get out of the heat?
That's correct.
Oh,
And you know what? I don't know that we even need these columns here anymore. We could just go straight to the electron configurations. You know, I listed these just to help you kind of keep up with things. But we could. We could put. Well, I did oxygen already. It's right here.
Do you want us to go any further than that?
For right now. We'll be going further, but right now we're going to stop there.
Can you say 8 electrons in the second primary level?
Mm-hmm. And that's really critical that you understand there are 8 electrons in the second primary level. Because once we fill all the sub-levels up in the primary energy level, an atom is happy and is unreactive. It's not going to react with things to get or gain more electrons. Yes?
The primary use of energy level. You said in the second one it can be 8 or more?
On the second primary level, there are 8 electrons in the second and higher primary energy levels.
So can I ask you a question?
Yes.
Why do you have only 2 primary electrons if it's going to be 10? And for fluoride and neon. So we go on to the third level also?
Now we have a third level. When we get to the next element, we go to the third level. Is that what you're asking?
No.
I'm sorry?
You passed 8 on the second level already.
Right. Oh, but remember 2 electrons are in a lower level. So that's the primary energy level has 8 because 2 of them are in a lower level.
So we stop right there.
Well, for now. All right. Now I'm going to leave out these 2 columns now, okay? Let's just show the element symbol and how many electrons we have. Okay, got 11 electrons in sodium. We filled up this lower level. Those electrons are going to stay there in every atom that follows that. Okay? So for sodium then, we're going to have 1s2, 2s2, and 2p6. Those are going to stay there in sodium. But we're adding one more electron in sodium, but now we're in what primary energy level?
Level
3. So this last electron is in 3. What cell level region are we in? S,
What's that next to the P?
6.
Can you do the other two columns?
Because the larger, even if the larger sub-level, like the 3, it's always going to consist of the lower sub-level.
Exactly. The larger sublevels are going to include in that electron structure the lower levels.
Okay.
So I'm going to skip back here just a second and show you this concentric circles sort of map. Okay. So when we filled up neon with 8 electrons. Okay. So neon looked like that. All right. We've got this full. It can't have any more electrons. So when we went to sodium, we put an electron in a higher energy level, and that's where it is on our inventory, in a higher energy level. 3s1. Say again. Okay. You keep adding on to the lower levels is all you do. Yeah.
So we're still on level 2.
We're now in level 3.
Oh, S double.
So if you're
No.
still doing it, would be
Wait, why are we still in there?
Yeah, you could do that. SSPS, yeah.
The periodic.
All right, so you have to synthesize several different concepts here to make this make sense. You have to understand concentric circle mapping, showing the spheres where the electrons are located. You have to understand the regions of the periodic table, and then you just have to count your way through those. All right. Let me use a slightly different sort of mental process to get magnesium. And maybe it'll help you to see what's going on, okay? So magnesium has how many electrons? 12. All right, so here's our symbol for magnesium. And what I'm going to do is I'm going to use the periodic table to count my way up to magnesium, okay? I'll show you. All right. 1, S sublevel region, S, 1 electron for hydrogen. Helium's over here, 1s2. We're still in the S sublevel region. Next row is 2. 2s1, 2s2. Then we're going over to P. All right? 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. And then 3s1 and 3s2. Yeah, just have to put the other stuff before it. So once you fill up a sublevel, you keep it there, and you go on and count to the next ones. Okay? So 1s1, 1s2, that stays the same from then on out. 2s1, 2s2, that stays the same from then on out. So when we get the boron, it's got 1s2 and 2s2. And then we have a P, so that's 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. So neon has 1s2, 2s2, and 2p6.
So 1s2, 2s2, and 2p6 are the first 2 rows.
Exactly. That's the first 2 rows. And then we're going to start with 3. And 3s, this is the S sublevel region, so 3s1 and 3s2.
So everything else is the same as
That's right.
Is it going to be 3s8?
No, because S sublevels can only have 2 electrons.
So it's only going to be, oh, so S levels are always blank S2.
Or it could be S1 or S2, but it can't be more than S2.
It can't be more than S2.
Right, because look, how many electrons in each of these rows in the S sublevel region?
2.
Just 2 of them. How many atoms over here represented by the number of electrons in the P sublevel regions?
6.
6.
So
How about in this?
the P levels are only going to be 6.
Maximum of 6 in the P sublevel, correct. And here, maximum of 10.
Oh,
Okay?
okay, so the S is 2. The maximum is
Yes?
6 for a P.
Yes?
10 for
Yes.
What, F?
Except for D.
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 F is at the bottom.
Yeah, we're not going to do F. I just need you to know it's there. Okay? We don't go that far with F. We're going to stop right here. Yep. All right. So, neon has all that. That's going to be in the lower levels of magnesium. Okay? 1s2, 2s2, 2p6, and now we're ready to have 3s1 and 2. Right.
1 and
Oh my god.
Oh, 2.
Yeah, I said I was counting them 1 and 2. Okay, counting them for you, just counting them. That's all.
Just can't get 100 in this class.
All right.
Yeah.
So when we get to aluminum, what we're going to add to this?
1 on that is 3S.
No, but we're not on.
Oh dang. We're gonna add a P.
Not you can't have 3 electrons in S. You
Another
3P.
got to have a P. So 3p1. Okay.
Oh my God.
There's aluminum. We're over in the P sublevel region, right?
I'm gonna run out of paper.
It's got 13 electrons, so aluminum is 1s2, 2s2, 2p6, 3s2, and then 3p1.
And P can go up to 6.
3p can go up to 6. That's it.
Just stop at argon.
We'll stop filling that level when we get to argon. That's exactly right.
What you say?
She asked, are we going to stop filling it when we get to argon? Yes, that's correct. This is 3p6 right here. So we're going to stop filling the third primary level when we get to argon.
Sure.
Are we going to be able to use our periodic table on the test?
Yes. From now on, anytime there's a test, you can use the references. Okay.
Let's just be
All right. Let's see. Do we need to do all of these in this section, or can we just skip over some?
Yeah.
You want to do all of them?
No.
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 I thought
No,
that
this
was.
she don't know how to do it.
She wants to know, though. Give her a break. We should applaud students who really want to understand. Exactly. All right, then everybody do silicone.
I did that already.
There's silicone right there. Everybody do silicone.